Good afternoon. Thank you, Catherine. It's a great pleasure and honor for me to introduce Professor Carl Keen. Dr. Keen is Professor of Nutrition and Internal Medicine here at UC Davis. He also holds the Mars Chair in Developmental Nutrition in the Department of Nutrition at UC Davis. Dr. Keen is internationally recognized for his research on flavanols, the components found in tea, cocoa, and other fruits and vegetables, and their effects on health, particularly related to cardiovascular health and function. Many of you may be asking yourself, why do we need to know research about tea? We all know tea is good for you. And there's been thousands of years of people consuming it. But when you get down to the real research data, there's actually very little known about tea. This is important for a couple of reasons. First of all, if you want to make a health claim in this country, you need to have data, not just stories. Second of all, particularly as it relates to us in the UC Davis community, the kinds of research and development activities that we can do related to tea to find the treasures or even the hidden treasures about tea require a lot of the kinds of research activities that are done here uniquely at UC Davis. So to unlock the scientific story about tea and what some of the potential future issues are related to tea, please join me in welcoming Professor Carl Keen.
Well, I would say thank you, Robert, but he just stole my punchline, so we could truncate this. When I was first asked if we could give a presentation on some of the health effects of tea, I said that just simply would be way too broad. Let's narrow it down to one sort of area, and we'll take a look at some of the data and some of the concerns that Robert just expressed. I would argue it's a very common belief that tea, certainly one of the most frequently consumed beverages in the world, can provide a number of positive health effects. This is a short list. Hydration, no question about it. Psychological benefits, I think many of us would say we enjoy them. Some say you get glycemic control and diabetes. It's weight management, it's reduction in cancer risk, particularly for liver, blood pressure control, and then vascular health. The problem here is the word I have at the top, it's a belief. A belief is something that you have, that you intrinsically are sure is correct, but you don't necessarily have the facts always to support it. And that's what we'll do in the next 25, 30 minutes, is ask ourselves, well, how robust is the evidence underlying some of these beliefs around tea? And ask ourselves, well, really, has there been enough rigorous studies in diverse populations that has been done when it regards the health effects of tea? And if the answers to the above question is no, then we should ask ourselves, well, what are some of the critical research gaps that need to be addressed? I think to Robert's point, that's the sort of thing which can be done on campuses such as Davis and elsewhere. First, some good news. The Dutch have a very firm belief. This was only published a couple of weeks ago, but the Dutch food-based dietary guidelines, which are similar to ours, actually contain, under their higher consumption recommended, drink 3 cups of tea a day. So they put it in the same category of eat more vegetables, eat more fruits. That's a pretty strong statement. In the US, we do not have a similar recommendation in our guidelines. If we did, it would literally translate into the fact it would need to be made available through K through 12 in school lunch programs. So it's a very strong statement. We back that up with what the European Food Safety Authority thinks about it. This is a very busy slide. The intent is not that you look at every single word here, but basically EFSA was asked to look at the health claims made for tea in all these different conditions, which I just had on the previous slide. And suffice to say, a few years ago, they said, "Niet." No, 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 no. Evidence is not there, which is a bit stunning because EFSA, if anything, is an easier regulatory hurdle oftentimes than what we have in the United States. So there's kind of a disconnect here. So with that in mind, what I'd like to do is look at some of the data as it relates just to one of these factors, vascular health, see if we can identify where some of the weaknesses in the data set are. And then, and at the very end, we'll say, well, how do we go about trying to fix it? How do we put support actually into our beliefs? I'll start with an accepted fact because it could help put the perspective of what's wrong with tea in the right way. I would say it's a fact that people accept readily. Diets rich in plant foods, that would include tea, are associated with an overall positive health status, decreased risk for some diseases, particularly vascular disease and a small number of cancers. With that statement said, and my guess is everyone in this room would probably endorse that, one small point is typically not covered. We have virtually no studies that are intervention that actually say it works. In fact, our dietary guidelines had never been tested in a rigorous way in an intervention. So when I make the statement, well, where's the evidence for tea? Appreciate, I could say the same thing about many of the things we tell you. And as some of the folks about fruits and vegetables, and as many of you are probably aware, a few weeks ago, some committees are now saying maybe we got it wrong with fat. It's not such a bad thing after all. New York Times had a wonderful article, expose, 2 days ago on do we really know what good foods are? And it's not clear. And again, it's a lot because we carry beliefs as opposed to saying, where's the scientific rigor? When it comes to tea, as was elegantly demonstrated in the previous talk, one of the things it has a lot of are these phytochemicals, and specifically a lot of flavonoids. About 20 years ago, flavonoids got a big round of attention because there was a study that suggested that the flavonoid intake that people had was inversely related to their risk for cardiovascular disease. So the high flavonoid intake was associated with a decreased risk. A lot of problems with this particular study. It was a really limited number of phytochemicals, but it effectively got the field started. And I show the slide so you appreciate it's only been about 20 years that this has been an area that people have really been kind of excited by. And some of the polyphenolics in tea, I just show a very small number here, but it's the upper row, which are known as the catechins or the epicatechins, that we'll spend a few minutes on. They look chemically quite similar, and yet they act biologically potentially quite different. If you think back to the presentation we just had, one of the points that was made, again, really nicely, was, well, when you're processing tea, you're having different levels of oxidation, you're having different combinations of other nutrients, and if it turns out that these compounds in tea are what are driving some of the health effects that we think are there, a huge question we have to ask ourselves is, but which tea? Because we can't have it both ways. We can't say that, oh, this epicatechin or the catechin are good for you, but it doesn't matter if we oxidize them or don't oxidize them. And so one of the things that we have to be looking for is really characterization from the health effects tea the same way it's being characterized for what is the aroma, what is the taste, what is the color. I want to stress that, well, the picture which I'll be building for you is talking about largely some of these catechins and the epicatechins. People hear about tea catechins all the time, and that's what we'll focus on. I do not want to imply that that's all that's driving some of these health effects of tea. As again was just put up in one of the previous slides, we have vitamins there, we have minerals, we have a lot of different acids, we have amino acids. Some of these get a lot of attention. The caffeine, theobromine, quercetin, most likely have health effects, but one has to know how much you get in a given tea, how much a person's exposed to through that tea, as well as through other sources in their diet. And we have very little information in this regard. One of the earlier papers, when they started saying, well, is there anything to the tea study? It was a meta-analysis where Peter's group asked the question, well, if we take a look at what has been published, most were relatively small studies, and 10 were cohort studies, 7 were case controlled. They said, let's add them all up together and just say, do we even see that there's a change in the relative risk for myocardial infarct? It turns out that at the 3 cup per day increase in tea consumption over no tea consumption, they calculated it around 10 to 11%. That is a big number. And in fact, if you ask yourself, well, where did the Dutch come up with drink 3 cups a day? It's not clear in their writing, but it's kind of nice that it actually parallels where some of the early meta-analysis studies were suggested it might be the case. Now, shortly after that paper, ARCH took a slightly different approach in their group. They said, well, what if we just look specifically at the catechin? Can we look at a group of individuals that's known as a Zoet-Van study and then say, well, we don't necessarily believe some of the epidemiology because it's asking people for food records and diaries and what did they remember doing. So this was a prospective study where they followed males for several years. They determined the intake of catechin as well as gallocatechins, different forms of the catechin, as well as the epicatechin, and did very careful analytical work and came up with the following conclusion. It wasn't just tea they looked at because it was their interest were the components that were in the tea. And they found the catechin the total intake was driven primarily by black tea, but also followed by apples and chocolate. And we'll come back to the apples and chocolate. It might seem like an odd combination, but it's really very intriguing here. And they came up with a number which was remarkably similar, and that is they got about a 20 to 25% reduction in risk with as little as 50 milligram increase in catechin intake. So again, these are awful big numbers. Many of the recommendations that we take from our public health officials, such as reduce your risk for trans fats, the hypothetical reduced risk you have for cardiovascular disease is nowhere near these sorts of numbers. So you start asking yourself, well, this is intriguing. How strong is it? Myself and Penny Chris Etherton at Penn State, shortly after that one, did our own sort of meta-analysis. And to be honest, we simply couldn't come up with the same robust finding. We saw hints, we saw trends that when we looked at cohort studies or we looked at case control studies, that when just focusing on tea by itself, it looked promising, but as is often said by almost every scientist, more research needed, had to be the punchline at it. Again, this was only a little over a decade ago. A key breakthrough study was done by a group by Mink who looked at several thousand women, and this time they went back to the food approach where they looked at flavonoids. And they said, first off, what foods, if you consume, when you have large Ns, 20 plus thousand, can you actually show drivers towards reduction in cardiovascular disease? And the foods they came up with were apples and pears, red wine, tea, and chocolate. Some could argue almost a perfect diet if you just have a few spices in there. Notice that the amount that they had to take was just more than none, which is, kind of astonishing, but a very robust paper. And it caused a lot of people to go back and start taking a hard look at these. And tea in particular, if you think that it's one of the major flavonoid classes, you notice on to your right where the flavin-3, so a specific type of flavonoid, one of the principal contributors to it happens to be tea. And that's true in many countries. So this starts getting exciting. Now you can say, well, it's not just the flavonoids in tea or the flavanols in tea, but we'll start paying attention and see if we can get one category, which are known as flavin-3. That's your epicatechin and catechin, if that's contributing more than anything else. And this was a chart that some colleagues of mine in Germany, we put together a few years ago and said, well, when we look at different type of flavonoids, where are they concentrated in our normal typical diet? And you see on your right again, there's the flavanols, and it's primarily driven by cocoa, red wine, apples, and tea. So this same cluster of foods that were popping up when you simply ask the question, can we identify foods to be associated with reduced risk, happen to also be the ones which are particularly high in flavanols. And that led to some speculations. One is that, well, we'll assume it's real, then we'll say the inverse association between the consumption of plant food-rich diets, including tea, and the risk for vascular disease is due to numerous factors, including flavanol-induced changes in oxidant production, so it's antioxidant, immune defense, platelet reactivity, vascular reactivity, tissue repair, blood pressure. So we very cleverly covered every single base we could think of, so later we would probably say, we got at least one or two right. But it also speaks to the fact that this is working through maybe multiple pathways, which makes it very difficult sometimes to identify what sort of evidence do we need. And a few years ago, there was an appreciation that we really were doing a bad job, I think universally, about what are good foods, what are bad foods. And to some extent, it's because we don't have very good biomarkers, particularly for the phytochemicals, and we still don't. And so one of the key things that EFSA is asking for, and our own FDA is asking for, is show us that you have markers that actually translate into, we can show you actually did consume that apple, you didn't just buy it, but also that we can mechanistically say it's having effects. And this is not as straightforward as it sounds. We talk about catechin, epicatechin, and if I give anyone in this room right now a nice glass of tea, I can measure about 2 hours later an increase in that epicatechin or catechin, or at least the metabolites in your blood. But if I look at you 4 hours from now, I'm not going to see anything. So these are very fast cleared from the body, which makes doing biomonitoring quite difficult. The other thing is they're very quickly metabolized. That's what that pie shape shows. We don't see any of the native. We don't really see epicatechin within the bloodstream, or catechin. We see metabolites of those. That's pretty key, because when people used to say it's the antioxidant, and you'll see ads all the time for the antioxidant capacity of tea. Well, that's wonderful. Maybe if you're a little container that tea's poured into. But as far as your body's concerned, it doesn't see those compounds. So we can almost throw out the antioxidant hypothesis, which has really kind of been the soup du jour for a long time. Question, though, is antioxidant activity, are we losing something there? Is that a viable way that, say, the NIH or USDA will accept it? EFSA reviewed all the literature on antioxidants and cardiovascular health and basically said, don't send us more of these. Because unless you can actually show that within the bloodstream or soft tissues it's acting as a true antioxidant, the claims are largely incorrect. There is an area, though, this is a very busy slide, but what I want you to see is most of the arrows are all going down, and it's looking at platelet reactivity. And for a number of reasons, our group, as well as multiple groups globally, said, do we see effects on platelet reactivity? And it turns out a very consistent observation, again, within 2 to 4 hours, if you take a high dose of a high flavanol-containing food or beverage, you could oftentimes show reductions in platelet reactivity. This, in theory, reduces your risk for stroke. To put the number in perspective, this slide is here just to say it's about the same order of magnitude that you can give, say, from cocoa or tea, as you can get from low-dose baby aspirin. So we're talking within the physiologically and pharmacologically important realms. Is this an acceptable biomarker, platelet function? And the answer is yes, according to EFSA. EFSA says if you show reductions in platelet reactivity, we can give you a health claim on that. The U.S. does not do it. So this is where we have some divergence of what's acceptable, what's not acceptable. But it's you can say, well, wait a minute, but a few minutes ago you said EFSA looked at tea and they didn't accept the health claims. This was not for tea in this particular case, was a tomato concentrate. What EFSA said is tea has promising data, but there's not enough of it yet. So we move to another endpoint, and this is known as flow-mediated vasodilation. It's a fancy way of saying that if you have a constriction, say, around your arm and you have an episodic event, you need to increase blood flow, there's a series of mechanisms that does that, and it's caused by increasing the production of nitric oxide, a gas within your bloodstream. And we can measure that. And there is some hints in the literature that flow-mediated dilation could be increased by some compounds, including flavanols. And these can be very quick. This is a slide that was done not with tea, but with cocoa, but the same principle. Within about 2 hours after you consume a beverage, you can measure the increase in your endothelial's ability to expand and thus improve blood flow. And you can correlate that very closely with the gas nitric oxide or with the compounds itself. So mechanistically, it has an underpinning. More informative is, at one point, some work that was done by Hagen Schroeder and with our group. He said, well, we should be able to strip down that cocoa beverage or that tea beverage to single compounds. And if you simply give minus epicatechin at the same level that you get if you give it in a complex beverage, you get the same positive FMD response. Now you have a reason to say there's not just this smear of all these phytochemicals in some beverages or foods, but there's specific ones that we know that when consumed at the levels that they're commonly present at can have these effects. Very busy slide. What I want you to cast your eye on is to the right-hand side, almost all investigators globally are finding the same thing. So it's not a case of where there's too much equivalency. What you might also notice if you look at the type, you see very few examples of tea. The tea industry, the tea research group have frankly lagged behind some of the other foods. So cocoa has already gotten some health claims based around this. Tea, I'm quite confident will, with a little more data, because there is hints of it, not even hints, there's been reports, it just isn't, they're not large, that with both acute tea and chronic tea consumption, you can see this increase in FMD. And importantly, you can show that in individuals who even have vascular disease, such as coronary heart disease. And it's not just black tea, you also see it with green tea, which I find intriguing because the epicatechin content of the two can be very, very different. Though in these early papers, hard numbers were not given in terms of what the concentration were. So if you take a look at chronic flavonoid intake and flow meter dilation, here the story looks a little bit better. If you collapse multiple studies together for both black tea and green tea, you can see increases in FMD, so quite encouraging. And it's also clear that if you do this in different doses using relatively healthy people, so the average person in this room, and you're doing it around 400 to 800 milligrams of T flavonoids a day, you'll get these nice increases. And not only do you get increases in FMD, but you get a reduction in what's known as peripheral arterial stiffness. And as you get older, it becomes harder for your vessels to actually show elasticity, and that's known as aortic stiffness. And some of these compounds look like they can effectively start to reverse that, which is quite exciting. And in a very nice dose-dependent manner. This slide I put in here, though, to really drive home the point that it's a world of difference if someone says they're a tea drinker, if they have 1 cup a day, 2 cups a day, 3 cups a day, because quantitatively we can show biological effects associated with those small amounts. Recently, this is the 2011, the tea consumption was looked at also from a meta-analysis, and the answer was it was very strong effect. So probably one that would rise to the level of saying a health claim's possible in the future. A very intriguing paper that just came out last December is some clever scientists said, well, if this is what's happening, then we can go ahead and take the compounds that are stimulating this production of nitric oxide, knock the enzyme out with an experimental animal, because this would not be a good thing to do in a human, and ask what happens. And it turns out if you knock the enzyme, which is known as nitric oxide synthase, out, you then can go ahead and feed the type of catechins that you have in tea, and you get no effect. So that starts to give us a good mechanistic loop, fits the matter. Is this an acceptable biomarker, FMD? And again, if you happen to be in Europe, EFSA says, you betcha. In the US, it's still not accepted. So, we have this kind of dilemma that some of the biomarkers which are used in some countries are not used in other countries, but ultimately I'm quite convinced we'll get consensus around them. And there's one other way that you can do this, and that's you can measure the blood flow in your hand. And this is microcirculation, slightly different. And a very nice paper came out recently that said, you can even with tea theaflavins, so these are the oxidized catechins, we also get this effect. So quite promising. There's some difficulties in this type of work that you just have to be alerted to. In this particular study, was using cocoa, as you go from your left to the right, what you notice is the effect seems to be getting smaller. It's because we're watching the change in vessel dilation. And this change, by the way, is about the equivalent of taking a person who is a smoker and giving them some of these, and now their FMD response looks like they don't smoke anymore. That doesn't mean you get to smoke if you drink tea, but that's the magnitude of the effect. But if it's done chronically, you don't see the acute effect. So in any type of study where you're asking what are the health effects of tea, you really have to separate out if people are kind of naive as it really results to drinking tea, or if there's somebody who's already belting 4 or 5 back a day, because you won't measure an acute effect then. One of the things that is exciting is this aortic augmentation is the same, it was what I was referring to a minute ago, where you get a stiffening of the vessel. In the elderly, this can be quite a problem. And over a period of time, such as about 2 weeks, you can effectively make their system look much more like that of a younger individual. And this has recently been looked at again with the black tea and saying, well, do we change blood pressure and do we get these changes in wave reflections? And that's another pulse wave velocity. And again, they were able to demonstrate it in literally a very short time period in hypertensive patients. One reason I find this exciting is you can now buy what appear to be almost like bathroom scales. They're kind of pricey, but they're there. That along with getting your lean body mass when you get on the scale, so it just doesn't tell you weigh too much. It says you're also maybe a little bit too fat. You can also get your pulse wave velocity. So you think about it, in the not too distant future, now if you want to spend the money, you can actually ask yourself, am I improving my vascular health? So you don't rely on seeing your physician once or twice a year. Is this an acceptable biomarker? The arterial stiffness, and again, it is in Europe, it's not in the US. And I put this in only because those last slides were in black tea. You also, based on some very recent meta-analysis, also get effects on blood pressure as well as lipid profiles with green tea. So even though you change the chemistry of some of these, the catechins and epicatechins, when you have the oxidation process, in both cases, we get these positive effects. And the most recent one of these was actually very strong. Again, it was about a 10 to 15% reduction in cardiovascular disease risk. I will point out, though, that as opposed to when I showed you that slide for platelet reactivity and I showed you the slide for FMD, I noticed almost all the arrows, very consistent observations. If they're well-powered studies, you see the effects. You don't see it with blood pressure. Sometimes you find effects, sometimes you don't. And this has been strewn out throughout the literature. And it could be one of the reasons that so many dietary studies don't work as well. As long as we're only using blood pressure as our surrogate endpoint, we're going to come up with this kind of mixed answer, as opposed to some of the other surrogate points which are currently being used in Europe. And I'm going to finish with one more kind of enticing and really intriguing possibility. All the mechanisms we're looking at is how well is your vasculature working. In the last several years, there's been interest in something called circulating endothelial progenitor cells. And they're not stem cells, but I'm going to pretend they are for a minute because you'll instantly go, they help stimulate vessel regrowth and tissue repair. And it's been known now for a little over a decade that if you have a high number of these cells in your circulation, you have a reduced risk for death by cardiovascular disease. And you have a better endothelial relaxation. So low cell number, bad idea. This is not, again, not done yet with tea, but I think it will be an intriguing study. But we asked ourselves if the Flavanol, so the same compounds in tea, can help even if you have fully medicated coronary arterial disease patients. And just do it over 30 days. And I stress, these were folks who were getting what we thought was the best medicine that they could get. Follow them for 30 days, where they were given some of the flavanols to consume, in this case by cocoa, but you could imagine that similar type data may be generated with tea. And you see this improvement in FMD in that 30 days. You see reductions in blood pressure, but particularly exciting is you see increases in these circulating angiogenic cells. That implies that even if you have potential damage that's already occurred to your vascular system, you might be able to repair it. I mean, this is shocking to those in cardiology because the mantra 10 years ago was once you've done damage, you're not going to fix it. Just don't let it get worse. Well, this actually says, wow, maybe with the right approach, we can make things better. And there is an intriguing paper that was done with green tea consumption where they looked at just these cells, and they also saw improvements in cell number. And they did it in chronic smokers. So very promising news in my opinion. And the last kind of one to tease you with is a lot of excitement recently is around can it also influence cognition? one of the things that you hear about tea drinkers, cocoa drinkers, wine drinkers sometimes is it seems like their cognition is slightly better. And it turns out that when they took individuals relatively naive to high levels of these, only for 3 months, you could argue that's a long time, had them on high flavanols, there was increased brain blood flow, but specifically in the dentate gyrus. The dentate gyrus is critical in terms of how we recall information on a short-term basis, as well as perform simple tests. And they saw not just improvements in the blood flow to the dentate, but there also mild cognitive impairment was reduced. So a lot of excitement in the field that begins to say mechanistically, maybe when people say they feel better, there's actually something to that. How do you use this data? I particularly liked the discussion of the cultivars in the previous talk. The emphasis there was largely on taste, the aroma, yield, et cetera. But don't forget, we can also get the cultivars which are going to be changing in terms of what their epicatechin, catechin, or other target molecules are. And indeed, the USDA a few years ago said they thought this was a high priority research area. I don't think it's been all that aggressively pursued because it's the same thing. Where's our readout? What if we know it's really working or not? Well, if we take some of these biomarkers for physiological effects, couple them with chemical compositional data, it's now within our grasp. One of the folks I was talking to some time ago said, no one's going to really necessarily care though, because we do everything based on taste. We're going to take the cultivar that has, not necessarily the best health effects. We'll tell people we will, but we're really going to go after taste. And I have to point out that at one time, the idea of anyone drinking skim milk would have been aghast. It's ugly stuff. Now, if you give the average person whole milk, they don't like it. So taste changes, particularly when you become convinced or you see data that suggests that this different taste is associated with improved health benefits. So I think it's just a challenge to leave you with. And also, we have to be careful about the processing. The strongest data we have, I'm only referring to the flavanols, the catechin, epicatechin, is that it's the minus epicatechin is driving some of this. Well, as you heat a product, your minus epicatechin isomerizes, and it becomes suddenly minus catechin, and it doesn't flip back that easily. Why is that important? We have some data, and others are generated, some that's complementary to this, that these seemingly look the same. They're just mirror images of each other, differ tremendously in their biopotency. So it's not just what is the content that we potentially get in different cultivars, but we might ask ourselves, particularly if you're trying to get a tea where you're consuming it regularly for health benefits, not just because you really like the taste or the aroma, it may guide the type of tea and the way it should be processed down to the water temperature that it's actually heated at. So in summary, I think the majority of literature concerning and I still use the word potential because until it gets a little bit stronger database, its potential vascular health, I think is very promising. There are a few things we have to do, though, if we really want to move the field forward so that we're talking about solid-based evidence recommendations versus our beliefs. Not going to go through all these, but it's really simple. It's like when I say that is what do we do with our observational studies? Well, we have to use appropriate populations, and we have to follow them for long time periods. A lot of the data I showed you is for 2 weeks, 3 weeks, 4 weeks. Most of us don't care that much what a 4-week window is. What we really care about what happens over the next decade or two. So it's going to be a long time before we get really strong answers in, but we have to start somewhere. And we have to ensure power is adequate. The average study that's been done in tea is oftentimes with 10 people, 20 people, when realistically we should be looking at 40 or 50. And we have to be careful to say, okay, are we really being fair? Do we have both sexes being looked at? Are we basically only looking at males? If you try to find data for female smokers, good luck. We got a ton of data on male smokers. It really is incorrect and bad science to assume males and females respond the same way to this. We need better exposure assessments. And this is going to be tricky because of the fact that these are fleeting in terms of their biological life, the catechins and the epicatechins. And in clinical studies, what we need is also extremely well designed characterization. What is it we're actually giving to people when we say we're giving them 2 cups of tea? You can go in the literature and oftentimes you'll find very poor or very scanty characterization of what the actual compounds are. And we need to do interventions where we have some type of placebo control, so that it's characterized, but we have some type of control. But I think one of the most important ones is we need these intermediary and health outcomes where we have surrogate outcomes. And what I'm referring to is the classic way people would do intervention trials for vascular health is you run them for 10 years and you count the dead bodies. I find that really not a good approach. So we need to coalesce around this. And I think if we can get Asia, we can get Europe, we can get the Americas on the same page as to what are acceptable markers, we'll make a lot of progress across the whole food arena, but particularly for foods like tea, where I think there's a really building, and I would argue almost compelling case that yes, it has health effects, but we do have to be careful that it don't try to pretend it's a panacea for everything. That very long list that people were saying it does everything except cure your warts, that's not helping us. We should say, what are the 2 or 3 health conditions we think it will really make a strong difference in, and be aggressive about identifying those. And I will stop at that point.